Welcome everyone to a very special high-altitude strategy session. Today, we are flying at maximum altitude with a Top Gun level computer science Cambridge exam strategy. We are tackling Cambridge AS and A-level computer science, specifically subject code 9618, and we're going to take a direct peek behind the curtain at what your examiners truly want to see on your paper. Now, whether you built your foundational skills in syllabus 0417, 0478, 0983, 0984, or 2210, those were all your flight simulators. Syllabus 9618, that is the real deal. That is live aerial combat. I want you to imagine a high-pressure scenario. The clock is ticking down. You've got a massive, complex, real-world past paper question sitting right in front of you. Let me introduce you to two archetypal students we see in the exam hall absolutely every single year. First up, we have Alex. Now, Alex is brilliant at memorization. Alex will overload the page with raw computer science facts, spilling absolutely every piece of syntax they know onto the paper. But here is the problem. Alex provides absolutely zero critical analysis. Then we have Sam. Sam is the rusher. Sam rushes through the prompt, completely misses the crucial command word requirements, and dives straight into writing unformatted code without a plan. So, what happens? When the examiner's red pen comes out, both Alex and Sam lose massive points. They get shot down not because they don't know computer science, but because they completely misunderstand the rules of engagement for this specific exam. Today, we are going to fix that. We are going to transform those red pen marks into green check marks. I want you to look really closely at this number, 15%. I need to hook your attention right now by revealing that this single topic, the SQL DDL create database statement, accounts for a massive 15% of your total marks on paper 2. That is not just a passing grade, that is the fundamental difference between an A and a C. It is the literal difference between just scraping by and achieving absolute exam mastery. A lot of students look at SQL DDL and they think, oh, it's just about memorizing syntax. I'll just write create table, I'll define a few basic fields, and I'll move on. But Cambridge examiners are hunting for something much, much deeper. They are actively testing your ability to construct a robust, conceptually sound database foundation from scratch, based purely on a provided, messy business scenario. This isn't a hurdle, it is a massive, golden scoring opportunity if you know the exact flight path the examiners expect you to take. Okay, let's dive into this and map out the structured masterclass we are about to cover. First, the 15% opportunity. Second, core exam assessment objectives. Third, the method mark strategy. Fourth, top 3 examiner warnings. And finally, mastering critical analysis. Let's start with section 1, the 15% opportunity and unlocking the real value of SQL DDL. We really need to reframe how we look at the create database statement. Like I said, it is not just a technical syntax hurdle. When you look at the Cambridge syllabus, database creation represents the absolute foundational layer of data management. Think about it. If your data definition language is weak, your entire data structure collapses. Examiners use the create database statement as a proxy. They use it to test your broader logical thinking. They want to see if you can look at a chaotic, real-world business scenario, extract the vital entities, determine the precise data types, and build a structure that forcefully enforces data integrity. It is quite literally about translating human chaos into machine order. So, what is really interesting about the foundational definition we use here is that it explicitly draws on systematic analysis, logical structured reasoning, and evidence-based database decisions. Notice what is entirely missing from that definition: rote memorization. Examiners explicitly prioritize analytical depth over superficial breadth. They do not just want you to write the word varchar on the page. Anyone can memorize that. They want your evidence-based reasoning for exactly why you chose varchar instead of a fixed char for that specific business case. Moving right along to Section 2, Core Exam Assessment Objectives. What are they actually testing under the hood? To absolutely beat the Cambridge exam, you have to think like a Cambridge examiner. You have to understand the specific command words they use. We're talking about words like identify, describe, explain, and evaluate. Remember Sam, our rushing student from earlier? Sam completely ignores these command words. If the prompt clearly says, explain why a relational database is appropriate for this scenario, and Sam just starts writing SQL code, Sam gets 0 marks for the explanation. 0. The examiners are specifically targeting 3 cognitive domains here. First, knowledge and understanding. This is your baseline, knowing your primary keys from your foreign keys. Second, application of concepts to unfamiliar contexts. Now let me ask you, why is this often the hardest part for students? Because you might practice with a simple school library database, and then the exam hits you with a database for a global satellite tracking system just to throw you off balance. Third is high-level analysis. To conquer all 3 of these, top-tier students use the PEL framework. Point, evidence, explanation, link. You make your point, like stating you'll use a Boolean data type. You provide evidence, noting the exam prompt explicitly says the system only tracks active or inactive states. You provide the explanation that a Boolean is the most mathematically memory-efficient way to store binary states. And finally, you link it back to optimizing the database for the given business scenario. Before we continue, subscribe to our YouTube channel AC Exams at acexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Welcome back. Let's push into Section 3, the method mark strategy, securing points through process. So, the crucial point here is that in Cambridge computer science exams, marks are frequently awarded for the process itself, not just the perfectly compiled final code. If your final SQL has a slight missing comma or a tiny syntax error, you might lose one accuracy mark, but you can actually scoop up the vast majority of the marks if your method is logically sound. This is the ultimate safety net. This is the exact strategy that transforms Alex and Sam's red pen marks into green check marks. Let's walk through this exact deconstruct, solve, evaluate, problem-solving framework, our computer science success blueprint, that top-tier candidates use. Step 1. Identify given information. When you read the prompt, physically underline the nouns. Those are usually your tables. Underline the adjectives. Those become your attributes. Step 2. Break into logical steps. Never just start coding. Map out your entities on a scrap piece of paper before writing the actual statement. Step 3. Solve systematically. Define your data types, define your primary keys, and then define your foreign key constraints in that exact order. Step 4. Check for reasonableness. This is huge. If you set a high school student's age as a float data type, is that reasonable? Absolutely not. An integer is perfectly sufficient. Step 5. Make justified recommendations. Bring back that Peel framework we just talked about. This guarantees the examiner clearly sees your logical reasoning and happily awards you all those method marks. Now, this brilliantly illustrates the procedural framework in action. Look at how algorithmic thinking and data interpretation literally work hand in hand to secure those method marks. On the left side, algorithmic thinking involves step-by-step decomposition and selecting the appropriate data structures. When you are writing a create database statement, choosing between a full date/time format and a simple string for a timestamp is a critical data structure decision. It changes how the system operates. On the right side, data interpretation requires you to extract from representations and draw evidence-based conclusions. You have to actively interpret the messy, real-world business rules provided in the exam prompt and logically translate them into strict SQL constraints, like check constraints or not null declarations. You can't have one without the other. Stop scrolling, subscribe to our YouTube channel AC Exams at acexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's dramatically shift gears into Section 4, Top 3 Examiner Warnings, the trapdoors to avoid. For this section, we are pulling insights directly from the principal examiner reports. These are the people grading your papers. Let's do an interactive workshop right now. I want you to imagine a complex computer science data table on your screen. Challenge 1, data scan. If I gave you a 60-second visual countdown timer right now to scan it and extract the core trend to build an SQL table, what traps would you fall into? Here are the top 3. Warning number 1. Confusing cause and effect in SQL statements. Students constantly misunderstand how foreign keys enforce referential integrity, and they end up creating disastrous circular dependencies. Warning number 2. Forgetting to check boundary conditions in edge cases. Challenge 2. Find the flaw. If you define an integer field for a scientific temperature reading, do you remember to write a check constraint to ensure it doesn't fall mathematically below absolute zero? Examiners absolutely love testing edge cases to separate the A grades from the B grades. Warning number 3. Providing generic answers instead of context-specific ones. This is the ultimate trapdoor, and it is exactly what takes down our student Alex every time. I am going to read this exact examiner alert emphatically because it is one of the most absolutely crucial things you will hear today. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. And this brilliantly illustrates exactly why superficial memorization fails on Syllabus 9618. You literally cannot memorize your way to top marks here. You have to demonstrate live application. If the exam scenario is about a local hospital database, your answer cannot just lazily say create table patients. No, it needs to logically explain why patient_ID is a fixed-length string, directly referencing the specific numbering system described in the introductory text of the exam paper.
Let's move to challenge 3, speed writing. We are going to do a mental exercise to see this contrast in action. Imagine a 30-second timer to write one perfect PEL paragraph. On the left, we have Alex's deeply flawed generic approach. Writing standard SQL definitions without referencing the provided data table earns maybe, if you're lucky, 2 out of 10 marks. On the right, we have the Top Gun, context-specific answer. If the exam prompt provides a table showing product codes like A100 or B200, a context-specific answer says, the product underscore code field must be strictly defined as varchar 5 because the explicitly provided sample data demonstrates alphanumeric codes with a maximum absolute length of 5 characters. Do you see the difference? That sentence right there is exactly how you capture the marks. It uses hard, undeniable evidence directly from the scenario to firmly justify a technical, architectural decision.
Let's bring it all home with Section 5, Mastering Critical Analysis, Achieving Top-Tier Marks. This is where we present the complete computer science answering system to push you into the top 10% of candidates globally. Here are the 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. Rule 3, time management matrix, ensuring you absolutely never run out of time on a 15-mark design question. Higher order evaluative thinking is exactly what separates the good programmers from the great system architects. Top-scoring candidates always consider multiple database solutions. They don't just write code. They might briefly write, while a flat file structure could technically store this data, a fully relational database is strictly required to systematically reduce data redundancy. They powerfully analyze technical trade-offs using comparative connectives, words like however, whereas, and conversely. They humbly acknowledge the limitations of their approach, such as astutely noting that a specific check constraint might actually slow down bulk data imports. And above all else, they meticulously justify absolutely all decisions with concrete evidence, building a rigorously defended argument for exactly why their database is the mathematically and logically superior solution. To help you retain this complex terminology as your progress bar reaches 100%, here is a highly specific, actionable study memory hack. Create your own mnemonic for SQL DDL create database using the first letters of key terms. Think of the sequential steps we discussed. Define entities, determine data types, link foreign keys, set constraints. D, D, L, S. Whatever crazy acronym works for your brain, write it down the absolute second you enter the exam hall so you have a foolproof, tactical checklist to work against under immense pressure. Listen to me carefully. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
I want to leave you with this final, truly provocative question. Knowing that a massive 15% of your Paper 2 grade is completely on the line with this single topic, how will you adapt your exam strategies starting today to absolutely guarantee context-specific, evidence-based answers? You can no longer afford to be like Alex, recklessly relying on generic memorization, or like Sam, blindly rushing past the crucial command words. You are now equipped with the examiner's playbook. You fully understand the method mark strategy, the incredible power of the Peel framework, and the absolute non-negotiable necessity of critical, context-specific analysis. The next step is pure execution. Go pull up a past paper right now, specifically hunt for an SQL DDL question, and apply this exact methodology. Keep analyzing, keep practicing, and I will see you in the next explainer.